Hi, this is Rick, and this is all about modules. Modules are little pieces and parts of your program, kind of like those Lego things are over there. Now, realize that this is not going to take the place of your book. This presentation is simply an overview. It's kind of an outline of what's in the book. If you want more detailed instructions, they're going to be in the book. If you want better details about the examples, they're going to be in the book. So follow along, and don't forget that the page number is in the upper right-hand corner of your slide. So as we go through this, if some slides don't have page numbers, they're probably not in your book. You can just listen and sleep if you want to. Back in the day, we had some great advances in computer programming. One of them was the computer, and this is the first computer, ENIAC, born in 1946. Let's use an example for some of that computer programming advancement. Muskets that were made before 1866 were custom-made pieces of art. Someone had to customize them to your strength, the length of your forearm, how far you wanted it to shoot, what you really wanted to shoot. And then they custom-made the sling and the hammer and everything. But unfortunately, that didn't stick around long because it was too hard to replace those things. It took too long to build them as well. So Winchester came out in 1873 with a rifle that was actually disassemblable. So if you broke a part in North Dakota, you could go back to St. Louis and get that part replaced if you wanted to, or they could send you a part and you could fix it yourself, which was really nice because all those interchangeable parts made for a lot more flexibility and made for a whole lot easier fixes in the field. That same thing happened in programming. This is what a program used to look like, bundles and bundles of paper just all the way down, and no one ever understood what the program did except the original programmer. Now, after 1964, what we have are little things called modules. And they're parts. They're also known as methods, by the way. But the idea here is that they're made of little itty-bitty pieces. And it's kind of like buying a locker. You get into a locker and you see all these different files that you can use. Well, programs today are made up of little parts called modules. And that's what this chapter is all about. Here are our objectives. So how do we use modules? Well, modules are used kind of like that rifle had a main stock in it. Well, modules have main logic, and it's in this representation in a flowchart. You see this: you have a start, the main, and you have an end to the main. And in there, you're going to run a number of different things. You're going to have the program do a number of things. You're going to instruct it. So in our logic, we always have a main. But the inside is usually made up of little modules. They're specialized parts, and they're named for what they do, kind of like the sort and the pay do here. So let's talk about what modules are. A module is a group of statements that exists within a program for the purpose of performing a specific task. What we see is most programs are large enough to be broken into several different subtasks. So we divide and conquer. We actually go in there and build little pieces at a time. So why would we build little pieces and not just the whole thing? There are 5 benefits to building the program in modules. First of all, it's much simpler code because you don't have to worry about as much that is going on. For example, you have smaller modules are easier to read. You can reuse the code. You can reuse those modules over and over again as many times as you'd like within the program and with other programs. Makes for much better testing because you can isolate and fix the problem. The development is much faster. The development itself used to take years. Now it takes months because we reuse common tasks from other programs. And the other best thing about this thing is that it's easier to facilitate in teamwork because if you're actually working in a module, your module is very small and other people can understand it and you can share the workload. Take time now to stop and go do the checkpoint on page 85. So we've written our module. How do we then get it to work inside the program? Well, the code for a module is known as a module definition. The module definition might look something like this. It might say the module name is called show message, and notice it's got a parentheses afterwards. That means it's actually going to work. And then it's going to display the message hello world, and then it's going to end the module. Okay. So how do we then do that? Well, to execute the module, you write a statement that calls it, and that's what we say. We call the module, and you might say call show message. Notice it doesn't say call module show message, it just says call show message. So how do we then define this thing? First of all, we want you to make sure that the module name is descriptive enough so that anybody could read the code and guess what it's going to do. And just like variables, we don't have spaces in module names. By the way, there's no punctuation. And just like that, you cannot start it with the number. What does a module look like? Well, a module actually has two parts to it. It has a header, and the header itself is the starting point for the module. That's what actually gives it its identity. And then we have the body, and the body is the statements within there. So we might have this, we might have module would be called name module, and then it might have a statement to run, an algorithm, and then an end to the module itself. When we look at it, a call must be made to the module in order for the statements in the body to execute. So what would that look like? Well, this is kind of what it would look like. The program begins, called module main. It's going to display, I have a message for you. Then it's going to go out and call show message, which is the module we've been working with. And it's going to say, display hello world. It's going to jump back to the main, and we're going to say, that's all, folks. And then the program will end. So we've got a main module, which is calling a show message submodule. And you want to be able to trace that logic yourself. As we do this, when flowcharting a program with modules, each module is drawn separately. So we might have something that looks like this. There's our main on the left and our show message on the right. On your own, trace the logic down so you can see where it goes over and grabs the module and comes back. We have what is called top-down design. Top-down design breaks it down so that the algorithm and the modules work on the following way. The overall task is broken down into a series of subtasks. Each the subtask is repeatedly examined to determine if it can be further broken down. And then each subtask is coded. That's what you're going to do. This is what a hierarchy chart looks like. And a hierarchy chart is really the way that the modules interact with the main program. It's kind of the detail of how the program is executed. And this is what one might look like. Whoa. Let's take a look at what are called local variables. This is one of those keywords that you want to make sure that you have in your vocabulary. A local variable is declared inside the module and can be only accessed by the statements inside that module. Now, the scope of a variable describes the part of the program in which the variable can be accessed, and variables in the same scope must have different names. Go back and do the review questions 1 through 7. So if we've got a main, then, which is going to call a module, then how do we get the data from the main to the modules? Well, sometimes one or more of the processes needs to have stuff sent to it. Now, there are two words for this. An argument is any piece of data that is passed into a module. So the main would say, we're going to send you this argument. On the receiving end, the module would say, okay, I'm going to receive that data and I'm going to call it a parameter. So that's the argument that is received. The argument and the receiving parameter variable must be the same type. Now, you can pass multiple pieces of information as long as you realize that they're sequential in the parameter list. So what does that look like? Well, here's an example. One of the big things about programming is programming security, and the way to make sure that the program itself stays integral and your data is not compromised is to realize there are two ways of getting the data from the main module to the submodule, and the way that we do that is called passing by values or passing by reference. If you pass by values, it means that only a copy of the number or whatever you're going to pass goes over there, and you can manipulate it and change it, and it doesn't change the original value that it came from. It's a one-directional communication, and the nice thing about it is it doesn't change the original. If you pass by reference, in other words, you tell the module where that data is, it can go back and change it. So if it multiplies it by 2, it's going to change the original by multiplying it by 2. And you may or may not want that, but it's a very good way to secure your programs. By the same token, you'll have this thing called variables. So we had local, and now we have global variables. That's the other kind, and that's a variable that's accessible by all modules. Basically, this is not a good thing. You want to avoid those whenever possible because, first of all, they make debugging difficult, but also it makes the module dependent on global variables, and it may be hard to reuse the module in the future. They also make the program very difficult to understand. So a global constant is like a named variable but it's like a constant as well. So that's available to every module in the program. Since the programs can't modify it, it's much safer than a global variable. Let's go check and see what we know. Our checkpoint is to go to page 118, which is the review questions, and do review questions 8 through 15.